Hello, everyone. So we are going to talk about Lambda and how we build a Lambda experience and how you can build your own Lambda experience at home. Not me, Héctor first. Héctor is CTO at Adhara, and I am Alex González. I am head of back at BBVA Next, and I am currently working at BBVA, which is a bank. So first, we want to start like breaking a myth. It's 2:50. You are in Spain and nobody's taking siesta. So please don't fall asleep today, okay, with us. What we are going to tell today is a true story, okay? Héctor, before abandoning us to being a CTO at Adhara, he was working with us at BBVA, and we were building this experience inside the bank. We end up with it at the end of last year, and then you left in January. But he was so involved, and I am so involved, and our team here is so involved as well in Lambdas. A little bit of context. BBVA is a bank. It's on the financial services industry. The presence is in more than 10 countries. We have data centers on-premise. We are using the cloud, of course, but we have on-premise important data centers in Europe and in America, and we have around 10,000 IT professionals. From these 10,000 IT professionals, we have high availability of managers, because if one fails, you can go for the other. And we are building these internal cloud services in 2014. It's not just this, okay? We are trying to build all the ecosystems with databases as a service, containers as a service, compute as a service. We have like a lot of different things. Today, we're just going to talk about Lambda. What we were offering before offering Lambda was this. Containers as a service in an experience something like Apengi or Heroku. So our developers didn't need to deal with what is behind, so we provide them with an API and they can deploy their services. We're basically simplifying the way they deploy something. They don't need to ask for metal to deploy. They just go to the API with their certificates and they can do a deployment. The next logical step was offering Lambdas, and is what we started doing. So how do you achieve it?
Okay, first thing is, okay, we are talking about enterprise ready. It's a difficult term to explain, I think, or maybe too easy. But I usually try to look at Wikipedia. If you find that term there, probably is the best definition you can find. In our case, I can remember if we didn't find that term in the Wikipedia, or it was something like a crappy thing that you cannot use or it's not meaningful. So Alex decided to ask the community, to ask you, okay, what's enterprise ready for you? And we get some interesting things. So let me show you some of them. Of course, completely agree. It's something that we cannot discuss. This is enterprise ready. And after that, maybe suits, money, of course. But I think money is everywhere, so it's not only about enterprises. And this thing that I don't understand too much, but it's funny. Trying to figure out what enterprise ready is, or at least what we understood when we were building all these kind of services, is that when you try to build something that need to be deployed or to serve to a company, probably you have some kind of industry constraints. In our case, it was mainly financial. It's a financial regulated industry. So security, confidentiality, data location, that was something, a kind of nightmare. As an example, Peru can store data in Mexico, but Mexico only can store data in Mexico, and sometimes can store data in Spain, but Spain yes, but not France. It's a nightmare. So at the end, there are a lot of things that you need to solve that every application that is built in the bank that will provide service to our clients need to be solved. So it was very to solve in the foundation, in all the services that we were building. So instead of spending a lot of time and money trying to solve this on every application, it was very to solve just in the basis. Of course, depending on the company, you are going to have some rules to follow, some tools to use. In the case of BBVA, it's a 100 years company. A lot of things are there. You need to use those things. Some of them are awesome. Some of them were awesome at some point, maybe 20 years ago, not now. And at the end, you need to integrate with a really Maybe it's not about ecosystem, but it's difficult to make something that interacts perfectly with everything. So, and talking about the Lambda experience or the experience, one of the lessons we learned failing a lot in the first years, probably the 2 first years of our developments, we spent a lot of time trying to solve all the security issues, all the things that were related with being a financial industry service. And what we provide to our developers was something that maybe it was not the best experience or it was not so useful for them. They used our tools, but it was like, because we need it. We don't have another option. Maybe it's, if you can build something different, it will be better. And we refactor everything. We rebuild our services from scratch. And for this exactly case, when we started building Lambda, and with all the experience of failing a lot in our first experiences, we decided that the user and the experience was the first thing to be solved. And if we are building something that you can find in public services like Amazon Lambda, Google Cloud Function, or services like that, where I love to use those services, probably because they are solving a problem that I need to solve, and probably because the experience that I have when I use those services is what I expect. So we decided to make this. We wanted a Lambda experience for our developers, similar to public cloud offering. Just that simple. Maybe simple to explain, not so simple to implement. And based on this, or these 2 principles, having in mind all the things that we need to solve that is related to be financial industry, BBVA related development, and trying to offer this, we started a journey that we are going to try to explain you. So, how we did it?
So, as Héctor mentioned, the first thing that we wanted to do with this service was offering a proper experience when you use it. So, we're on the bank, you probably know some windows with a lot of input fields and all that. At the APIs looks more or less the same, but in JSON. And with this UX, we were trying to simplify that. So at the time that we have this contract with our clients, with our developers from the bank, we are not going to change that and all the complexities inside. So for example, an API, a Lambda function for us looks like this. If you are familiarized with Lambdas in AWS, it's the same. The only thing that changes is the context, okay? But the idea is you have a class, and this class has a function. This is going to be the entry point for the Lambda function.
One thing, we started with Java, another fail in our story.
Well, you're a bank, you need to start with Java if you want users. So the thing is, we are going to have an output, which in this case, for example, is a string, and we are going to have an input, which in this case is a string as well, okay? The context is something that we use, for example, if we want to allow you to connect with other services from this ecosystem. So you can just use the context and create a client for using these ecosystems without dealing with it, okay? We are doing it for you. And for the administration of the Lambda functions, we were more inspired by how Google does it. So we create a RESTful API with Cruth to create read, update, and delete functions. This looks more or less like this. This is the real one. For the example that we are going to show later, it's a little bit more simple because we don't have a namespace. And the big difference here is that everything that you want to become a function, every piece of code that you want to become that becomes a function in the future is going to go through a pipeline. Okay, you cannot say, please deploy this code for me. We are going to go to the pipeline, and this pipeline is going to check the security concerns that we can have. It's going to have traceability and a lot of other things that it kind of looks like a green field, this Lambda service, but at the end it's a brown field because we need to interact with all these bank pieces that we have already, okay? Oh, so I forgot to show you this. This is a real function, okay? We have some out data. We have the entry point, which is say hello, and the in data, which is the first parameter. Those are types that you defined, and if we know how to serialize or deserialize it, it's going to be compatible with the Lambda server. The other things that we have is getters and setters because Java. And this is the experience that we want, okay? We have some code, we push it somewhere, something happens, and you're going to get back a URL. And this URL is going to be your function service. You don't care about how many instances do you have of the function, or if the function is sleeping or whatever, you just have a URL that you call and the function is going to work. This is for the sake of the demo, we simplify it a little bit, okay? So instead of having these pipelines that are going to build the function for you, this example just receives a field, which is the code. Oh, sorry, go ahead. Which is the proper function that you want to run. And we say the entry point from this function, which is a class, and the method that you want that is going to be the entry point. In the bank, what we have are things like, for example, the stack, which limits the number of resources that you can consume, or make some other configurations that you don't need to take care of. We do it for you. So our second decision, after we decide that we wanted a proper UX and we have this contract signed with our clients, is what do we have inside? And for what do we have inside, we were checking what we had on the Cloud Native Computing Foundation and in other projects, or we can decide and go with our own. So the state of the art at that time, which was last year, we were evaluating OpenWhisk, OpenFast, Knative, Kubeless, and some other. Some of them are really good, and they were offering part of what we wanted, but not all of it. So, for example, for us, it was really important to deal with multi-region and multi-tenancy, the way BBVA does it, and to integrate with all these pipelines. Remember, the pipelines were already there. We don't want to change all the bank. We can just change piece by piece. Compatibility with gRPC and some other. So we already had the implementation of something like Google App Engine, which was dealing with some of these problems already. Like, for example, logging, tracing, security, and so on. And we had some certified stacks, like you can just run Java in this version with this library and whatever. So we put them together, and we end up making a homemade project. So this is our decisions, okay? First one, we took the UX, and we offered this proper API to the client. We are instead creating something from scratch, reusing another tool that we create, which is App Engine. And we are using the certified stacks that we had already at home, and they are certified by security and all the other pieces of the bank. And whatever comes now, like imagine that Knative 2 comes to the market and fixes all the not problems really, fixes all our concerns, we can start using it and nothing is going to change. So basically, if we were on Greenfield, we wanted to build this. We wanted a euro. But the context was this. So 8-bit Super Mario is fine. It's a really fun game. And probably some of you play it, and I don't know if there are some millennials here. But the thing is, I am millennial. No, it's not like a bad thing being a millennial. The thing is that we didn't want this, okay? Because Super Mario is good for some things. The euro is good for other things, like you cannot buy a coffee with Super Mario. You can do it with the euro, but you cannot have that much fun with the euro, and you can have it with Super Mario. So maybe what we wanted was this, and this is what we built. It's not a completely greenfield project. It's maybe not a solution for everyone, but for the bank works perfectly.
It's still a coin.
Yeah, it's still a coin.
So next thing we started thinking about was about the control plane. What I mean when I'm saying control plane is at the end we are deploying a function for you, so we need to manage the life cycle of that function, to a startup server or some kind of binary or whatever that will execute what you have built. And of course, dealing with maybe it need to be scared, or maybe it's a stop and we need to start up again. Of course, we were using Kubernetes, so almost everything was really easy based on that, but at the end, it was something that we need to deal about. Let me use this slide because I think it's easier to explain with this. We have two services running. that looked more like the left side. So at the end, we built a control plane that was interacting with a lot of software and things around, gateways, load balancers, firewalls, the Kubernetes itself, deploying things. And after that, with a simple URL, you just call that. You are more or less, you have the vision that you are probably building some gRPC server service or HTTP service or something that was built just to be a synchronous call or whatever. But when we started to think on offering Lambdas, we realized that probably we need to make an extension of the control plane that we call caller manager. That at the end was, okay, maybe when you are calling a Lambda, we want to offer an improved experience. As an example, dealing with, okay, I can sleep your Lambda, but probably when you call that Lambda, we need to wake up again. So in that case, probably everything should be managed by some PS that interact with the control plane. As an example, to wake up, or in our case, to in the way we decide to build our Lambdas, when you code that code, we are not dealing with any protocol. It's just data. It's pure data. So it doesn't matter if it's gRPC, if it's an HTTP request, or just something called from a queue. So you are completely agnostic. So that caller manager allowed us to offer that experience to our developers. So it was one of the biggest changes. Probably the control plane was quite similar to things that we built before, but this caller manager was one of the new pieces that we need to build and we need to deal with. Let us show you a little bit how this can look. That it's been.
Yeah. So we have simplified all this, and we put all the pieces together to make this demo. Okay. This code is going to be available later on GitHub if you want to play with it. So we have defined a type. This type is going to receive the code and the entry point. The entry point, remember, is the class and the method, and the code is all your function. Internally, we are storing it with an ID, because to call the function, you need an ID. This is all in memory, okay? We don't even have a storage. It's a map string function or something like that. And we have a URL. The URL is something that our users are not going to see. The URL is something that we save to call the function from this caller manager. So the functionality, let's say, is there, but there are not two different services. It's all the same service. So if we see the methods that we create, can you see well at the back? Yeah? Okay, awesome. So we have a handler for create the function, which is going to receive this model. We have a handler to get the function, which is going to show you that model except the URL. And we have a handler for calling the function. The only important bit now that we are talking about the control plane is the creation of the function. The creation of the function is just going to do this. On Kubernetes, we are using Kubernetes behind, but our users doesn't know that we are using Kubernetes. In the bank, we are using OpenShift, because I know that there are some people from Red Hat there. And the thing is, we create a deployment. After we create the deployment, we create a service. And then later on, we are going to store the URL of that service for calling the function. And that's it from control plane.
Yeah. Of course, this is just something perimeter to your code. We still need to execute that Lambda function. And the next thing to think about is about the execution stack. We started with Java. It was quite used in the bank, so it looked like the best option at that point. After that, dealing with developers, they told us that they prefer Python or maybe Node.js, but okay, we needed to start with something. So more or less, the executing stack looks like this. Interesting part is that we try to be as immutable as possible. Of course, if we need to inject something and we don't want to have the image pre-built, that it was something that we didn't want. Sorry. We need something that we call here the init container bootstrapper. At the end, it was just a binary. It's a really small piece of code that was in charge of dealing with some credential, get the binaries. In this case, DB was jars, but can be Python code, Node.js, an NPM package or whatever, to download it and to place it in the right place. So the Lambda server can get that code and start executing that. Mainly, more or less, the flow was, okay, download the thing. In this case, in the example that we are going to show you, it's even simpler because the bootstrapper is just compiling the code, quite simple. It's not dealing with downloading or credentials. One, it's there. Some configuration is injected to the Lambda server. We have like a standard protocol internally on how to configure this. So the server starts and configures itself to only execute that Lambda function. You cannot execute anything that is not that function. Make some verification about the signature of the function, if it's there, if not, it crashes and you cannot do anything. And at the end, internally offers two endpoints, that it's a post and a get. The get HTTP endpoint is just to be sure that it's up and running, and the post is to execute the function. As you remember, we had something called the caller manager. The protocol between the caller manager and this server is an internal JSON RPC protocol. It's just two kind of messages that we support. So when the caller manager calls the function that it's at the end is received by this server, there is a listener, get the message, parse it, try to deserialize everything into an object, try to execute the function. If it runs okay, perfect, all the information is returned to the user. If not, it returns the error. It's quite simple. Why we did in this way, it was because, okay, we started with Java, but we wanted an easy way to add new languages. Python, Node.js were probably the most demanded one, or maybe Go, that was our preferred language in our team. So we decided to invest a lot of time in the experience, in those interfaces, so we were not coupled with Java or the way we build the things. So let's show you a little bit on how this was implemented for this demo.
Yeah, so again, for the sake of the demo, we simplify this a little bit. We are not going to have the init container with the bootstrapping. We are not even going to download anything, as Héctor was saying. We mainly get the code. So is this one here? So we get the code that the control plane was receiving, and we are going to compile it. After we compile it with reflection, we are going to instantiate an object of the class on the entry point. This is what the function executor does, and this is the important bit. So important things here. This request JSON reader is instantiated with the type that was your input param. So if your input param was a string, and here you are trying to read an integer, this is going to raise an exception, and we are going to return an error. But int or string is just simple types, but you can have there whatever you want. If we can deserialize it, it's going to be okay, and we are going to call the function. If we cannot deserialize it, we are not going to call the function. Then we invoke the method. The method is the full path of the entry point with the parameters and the context. And then we write the value. When we write the value, we are just serializing the output type of the function. And that's mainly it here. You want me to mention anything else?
Maybe you can, if you want to show the project structure with the 3 layers that we commented.
Yeah. This is.
Yeah, maybe it's a little bit difficult here. Maybe.
It's on GitHub.
Yeah.
Let's go for it because we are not going to see anything here. So.
Yeah, we mentioned it before that it's quite easy to add new languages. So let's demo time.
Yeah, now what we are going to do, we are going to create a function, and we are going to call the function. We have a minikube already running here, almost. It was good to check. And then what we are going to do in the app, in the top, maybe a little bit bigger, is start the function server. This again is the control plane and the execution plane all together, okay? And we are going to deploy a function. First we deploy a function, and then I'm going to show you what we are doing. So is the example example Lambda function that we created before, but what we are going to be doing is setting foo and setting bar, and then returning foo and bar all together, okay? So if we see the function call.json, we are sending two fields with 2 strings. And then if I go up, I'm going to copy how to call it. If you see, we are going to call it not the service in Kubernetes, we are going to call the caller with the ID of the function.
I love it when a demo comes together, Sigurd.
I don't know if you hear that, but basically what it says is the result. I love it when a demo comes together, which is concatenating the two strings. And that's it. We had a plan B, because when you work in a bank, you know that you always need to have a plan B, but it wasn't needed. The demo worked this time. And thank you. If you want the code, it's there.
Yeah. Yes, as a summary, maybe 2 or 3 main topics. Focus on the user experience. It's one of the lessons that we learned, and it took 2 years until we understood that. And as you can see, it's quite easy to implement something that looks like a Lambda. Probably the most difficult part is to integrate all these things in your ecosystem. Probably if you can choose OpenFast or Knative or whatever, and you can extend or make the minimal extension to integrate with your system, is a better solution. In our case, we have a mature solution that was more or less what we needed, and we decided to evolve that. But at the end, there are different options. Choose the best that fits for you. So if you have any question.
Come on, we were not that clear, and our English is not that good.
There,
Maybe you can short it, and we'll try to, or we share this. Yeah, okay, yeah.
Okay, so my question is, as far as I can see or I know, the main problem with this Lambda thing in Amazon is the cold starts. What I mean is that when I start a function, it may take 200 milliseconds to boot, or maybe 5 milliseconds to boot. It depends on Amazon. So, do you have such problem in your application? I'm not pretty sure, because you have a Java app, and if you have to bootstrap the JVM each time when a function is called, I think it's just too much.
Yeah, I can start, and then, so if I understood properly, you are asking about the times when we are consuming the Lambda functions, no?
Yeah, I'm asking how much time does it take to execute the Lambda function? Not the code that is in the Lambda function, but the bootstrap, the process that you actually need to share and to get the resources from the bare metal servers and so on and so on.
So the bootstrap time.
Okay,
go.
In our case, because of the pipelines that were mandatory, the time you need to deploy a Lambda was like minutes. So the spin-up time was not the real important thing. But basically, if you see the original implementation, the one that is deployed at BBVA, as an example, the Java function deployed from scratch, a clean, new, branded Kubernetes cluster, it was like 1 minute because of the cache of the images. After that, it was like less than a second. It was, why? Because we placed a lot of CPU there. Once we started thinking, because more or less Lambda was built like a bronze service. If you remember our first or second slide, we had container as a service, App Engine, and Lambda. Lambda was like the bronze one. So we were placing like 10% or 20% of a CPU, and it took like 30 to 40 seconds to spin up a really simple Lambda function. So it depends on the resources. We were tuning, and we decided to, okay, it will be slow, but it was what we needed. If, in our case, as an example, we can define at some point some kind of goal function with a lot of CPU, and in that case, it will be faster.
It works when it works. It's fine. Yeah. Thank you.
Thank you. It was another question here, I think. There. Can you?
Yeah, so I just want to mention that for us the bootstrapping of the function was not that important. Important was when we call them, and if you don't sleep the Lambda function, it's going to reply at the same time that a normal service will do. So it's kind of okay in that way.
Thank you for the presentation. Just a question on how do you scale actually when you have multiple calls to this function? Do you spin up automatically new pods, or how does it work?
We have new calls.
Yeah, that's
Sorry, I didn't understand you.
scaling. First iteration using the autoscaler offered by Kubernetes, just configured by default with the maximum amount of instances that you use or place in the creation call. Just that simple. It was our first version. We started offering to the users, so probably there at some point, part of the team is here, so you can ask maybe about the latest version, but probably will be improved in the future based on real metrics. BBVA has a really good metrics aggregation system, so at some point I think they will use all that information to make an improved scale. Now it's really simple. Any more questions?
Thank you for the presentation. So my question is, why didn't you use like an open source platform for serverless like OpenWhisk instead of reinventing the wheel, basically?
I'm sorry, but can you repeat it, please?
I'm here, by the way.
Okay. So the thing is that for us this project was not a greenfield project. You cannot get like Kubernetes and offer it to the people from the bank to use, or you cannot get some project like OpenFast, which is pretty cool, and getting the people to use it. It needs to integrate with a lot of things and in the bank's way as well. We are never going to show you what is behind. So we always try to avoid the locking by offering an API on top of it. So what we are using behind is what it changed, and maybe in the future we can use something like OpenFast, but at that time was not needed at all. I don't know if this answers your question.
Yeah.
And also take into account that it's not the same if you need to build something from scratch without experience. That was not our case. You know, you have 30 developers and people that is building this kind of services and this kind of tools, and have something that is quite similar. At the end, it's just to make a new service something that is quite simple. Any more questions?
Just wondering, what is the load on your system? How many transactions per second you can handle, and like how many nodes, how many CPUs? Can you give us some numbers if you can? I mean, it's a bank after all.
Maybe I can answer to that offline.
Okay. No worries. I knew that.
I understood that one, which is okay.
We can say that it's not too big, but not too small.
Okay, thank you very much.